In this video, I'm going over the interim review from our second day, and the focus is all of our statistics. But of course, just kind of going through and making sure that we were good to go with the graph and reviewing this. So like, for example, we're just identifying which characteristics are true, and we're selecting two of them. So like the first one, the y-intercept is positive. So again, the y-intercept where it's crossing, our graph is crossing the y, which is right here at 0, 12, which is positive. So that's already one of them. Now looking at our range. So our range is saying we're starting below, which yes, in the negative, and stopping at 20. But notice, are we going up to 20? No, we're even going past 20 up to 21. That's our highest y. So that is not our range because it's going up to 21. The function is increasing over all of this. So it's increasing, but then decreasing. So no, that is also false. The domain, nope, that is not negative and negative, right? So yeah, we could have all reals, but our x values are not going to be negative, negative. The axis of symmetry is at x is equal to 7.6. Well, keep in mind, the axis is what goes through the vertex. So clearly, the axis of symmetry is not here. So notice how here's your 7.6. That is a 0 or a root. So the axis of symmetry is actually at 3. So cutting through here at 3. So let's make sure then that the last is correct. So this last part is our true statement, that the function is positive, so up above, over 0 to 3. So from 0 to 3, is this positive? Yes, we are above, we're in the positive. All of this is positive. So that is our other true statement here. So now going through and reviewing with all of our stats. Here you are having to identify, and sorry, the directions I see got cut off. But for questions 1 and 2, you're identifying if it was a survey, observational study, or experimental study. So here in this first situation, they have divided calculus students into 2 classes. One class uses the calculators and the other never uses. So here the team lead will then determine the calculator use and how it affects. That means because these groups were created, there is control over 2 groups. One uses, one doesn't use. You are telling them what to do. This is an experimental study. You have control over these 2 groups. Now in question 2, as you're looking through and identifying here, in the end, during lunch, she distributed a short questionnaire, meaning a survey. She asked. So this is a survey. So question 3, which of the following is an observational study? So a research divides volunteers into 2 groups. Nope. So that is experimental. A company asks all the volunteers how they feel. Asks. That is a survey. So nope. Government agency sends questionnaires. Again, a survey. Asking. Nope. So let's check to see that D is an observational study. Company records the time it takes for people to park their car. So that is why the answer is D. You are just recording. You are monitoring. That is an observational study. Then question 4, which of these is stratified? So now keep in mind that we had multiple that were sampling methods that were fairly accurate. Now the most accurate is the simple random, right? Where everybody has an equal chance, right? You're taking from the entire 3,000 student high school roster and you're going to select 400 random names. That is your simple random, and that is the most accurate. Then you're going to have other options that were also accurate, like systematic. Systematic, if you recall, had a system to it, a pattern. So that was like every 5th student that walks through the doors, or every other student, every 3rd student. So that was a pattern to it. Then there was the stratified, but then also versus cluster. So the stratified and cluster, you divide into groups. So like the high school, you could divide into grade levels. So you're dividing into groups. The difference is the cluster is from the groups, you only survey all of the 10th grade students versus a stratified is then you survey 100 students from each of the grade levels. So you're taking from each of the grades, the groups, versus you're only asking one group, but every person in the group. So remember those differences. So if we're looking for stratified, we're looking for you're dividing into the groups and then you're choosing from each of the groups. So here, assign each high school student, choose every 10th high school. That is your system, systematic. Divide the high school students into groups and then randomly choose 10 students from each group. That is why this was your stratified. Question number 5. So here, given this situation, what was the sampling method? So she divided the population into 6 groups. So dividing into groups. So now we're down to stratified or cluster. So here, remember, conveniences, whatever is convenient for the person, easy access. Self-selected is your volunteer. So here, based on the groups, then randomly choose 2 groups and survey every student in each of the groups. You are surveying every person in the 1 or 2 groups. That's why this is clustered. And so now in this situation, we have multiple parts here. So we have 8-year-olds. Here we're talking about height and standard deviation. So here is our our mean for the height, normally distributed. So our mean is 50 inches for a height for an 8-year-old, and then the standard deviation of 2.5. So keep in mind, there's your mean, there's your standard deviation or the sigma. Calculate the z-score. So remember, z-score is we have our fraction. We always subtract the mean. We divide by the standard deviation. We always put first the value that we're trying to convert. So in this case, what are we trying to convert? The fact that Ava is 53 inches tall. So we're looking for that z-score, 53 inches tall. We're subtracting from that, what's the mean? 50. Then divide that by the standard deviation, which is 2.5. So notice how she is taller than the average. So you're going to get a z-score that's positive 1.2. So again, what does this mean? This means that this height is 1.2 standard deviations above the mean. So again, this height is higher than the mean and exactly 1.2 standard deviations above it. Now, what percent of girls are shorter than Ava? So that's your percentage, going back to probability. So this is when we would now have to use the calculator because we have to look for that percentage or probability. Now, option 1, you could use the z-score, 1.2, or we could set up and identify what is the lower bound and upper bound because we already know the mean and standard deviation, which is 50 and 2.5. So now the lower bound and upper bound. Well, we're talking about Ava, who is 53 inches. And we want to know the percentage or probability of a girl that is shorter than her. So is 53 the lowest or the highest if we want shorter than Ava? The highest, because everybody is shorter, smaller, less than. So 53 is the upper bound, meaning the lower bound is our -1 million. Now, we have been focusing on, right, with that use of the graphing calculator in second VARS. But now just to show you guys how to put this in Desmos, graphing calculator. So remember here now, we're going to go to Desmos. So now remember, you're going to type normal, because this is a normal distribution. So D-I-S-T. Notice how it straightens up, right? So you start typing normal distribution and stop. Then now we need to put in. So notice how here first, we're going to put the mean, then the standard deviation. So the mean was 50 with a standard deviation of 2.5, then close the parentheses. Now we're finding the CDF. Remember how we would use a calculator and we always use the option 2 that was the normal CDF? We're finding that cumulative again. So here we go. Well, the minimum has already been set to negative infinity, that negative 1 million, so we're good. But the maximum, what did we say? Well, what was the upper bound? 53. So we're going to go ahead and type in 53. That's the max, that's the upper bound, and here you go. So the probability or percentage is 0.88 or 88%. So again, remember here, so this is 0.88 if we wanted to round it 5, which is 88.5%. Remember, you have to type in that normal distribution. So now here with this next situation, we are looking for the z-score. So again, we are subtracting the mean, divide by standard deviation, and the x value is always what we are trying to convert. So notice by reading here, we are subtracting what is the mean. Well, the average, right? The average temperature, the mean temperature is 102. So that is our mean. Then we're going to divide by the standard deviation, which is 3.1. So what is the temperature that we're converting to a z-score? 100 degrees. So notice the setup here, and because 100 is less, you're going to get negative 0.65, which means that because it's negative, it's below the mean. Now in number 8, again, we're just practicing calculating the z-score. Again, x, the value you're converting, minus the mean divided by standard deviation. So here we go. What is the mean of this situation? Again, average, 28 years for the TV. Then what is the standard deviation? 3.1. So then what are we trying to convert? The TV, that represents how many years? 23 years. So again, we're going to put that in the calculator and you get B, negative 1.6. So now in number 9, just based on the answer choices, I can see that we're talking about our standard deviation and using the empirical rule. So I'm going to go ahead and set up the curve here. So we have a mean battery life of 9 hours and a standard deviation of 0.3. So if we were to create 3 standard deviations above and keep adding, this is now at 9.3, 9.6, and 9.9. Then we keep subtracting, right? That's 0.3. So now we're at 8.7, 8.4, and 8.1. We want to know what is the percentage of laptops from 8.1, which is here, to 9.9. So we are talking about 3 below and 3 above, which represented 99.7% of the data. So again, notice how here we're focusing on empirical rules. So setting up the curve. We have for our cell phone a mean battery life of 6 hours, standard deviation of 0.6. So as we keep creating, now we're at 6.6, 7.2, and 7.8. So then we keep subtracting 6, right, to go 3 below. So now we're at 5.4, 4.8, and 4.2. So now, what is the percentage of cell phones that have a battery life of 4.8 to 7.2? So notice how now we're 2 below and 2 above, which represents when we had the 2 below, 2 above, 95% of the data. So now in question number 11. So using this situation, this is our average, our mean, and here's our standard deviation, our sigma. 68% of the data. So that means how many standard deviations away from the mean? 1. So again, we'll set up our curve here to use empirical rule because of normal distribution. I've got 67,000. Now, we only need 68%, so I only need one above and one standard deviation below. So when I add the one standard deviation to 67,000, we're now at 70,500. Then if we were to subtract the 3,500, now we're at 63,500. So again, one standard deviation above and below. So that's why here the answer is A. So now in 11B, what is the probability that you have a salary at least 65,000? Now see how 65,000 is not on the curve? This is when we would have to estimate using the calculator. So setting up our lower bound and upper bound because we already know the mean and standard deviation. This is what we're using here, the 67,000 and 3,500. However, 65,000, use the phrase in front to help. At least 65,000. So 65,000, the lower bound or the upper bound? The lower bound, because it's at least the lowest. So that's when we would put positive 1 million, or if we can, we'll put infinity. So now let's see if you remember. Here we go. So we're going to go to Desmos, graphing, normal distribution. So normal distribution, boom, there we go, right? So now opening up and starting, we need the mean first, then the standard deviation. So the mean was 67,000, no comma yet, because then we use the comma to separate. Then the standard deviation was 3,500. Close the parentheses. Remember, we want the CDF, so we've got to check that off. Now, let's go back to make sure what's the lower bound and upper bound, because that's a minimum maximum. The lower bound, 65,000, the upper bound is 1 million, or we could now keep it as infinity. So here going back, we're going to put now the minimum, the lower is at 65,000. Keep the maximum, and there's our probability, 0.716. So then the next, what's the probability that it's between these two values? So again, notice not on the curve. So again, we're going to use lower bound and upper bound. Now notice here we have an increment. So we can use 64,000 as the lower bound, upper bound 71,000. Same mean and standard deviation. So again, going back to Desmos, we're going to keep that. But now we were at 64,000, but then the maximum was 71,000. Remember, right? No commas. And here's our probability, 0.67, and we can round this because of the 7 after it to 8. So 0.678 or 67.8%. So now with 12, we're talking about the sample to sample variability. So remember, from one sample to another, that's one sample's proportion, and here's another sample's proportion. So it's already been calculated, right? Like doing like a lower bound, upper bound, and that's the proportion, or that's the probability. So can this ever be negative? No. And we're just finding the variability, the difference between the two. So all we have to do is subtract. So remember that sample to sample variability, we are subtracting. So that's why the answer here is B. Then 13 is talking about margin of error. So this was when you have to create the interval to see if there's overlap. So margin of error is 6%. So there's one person, Smith, who is at 55%. So Smith being at 55%, so with the margin of error, add and subtract 6, so now 49% to 61%. Then Thomas is at 45%. Again, but creating that interval, add and subtract 6. So now we're at 39% and 51%. So if you need to see, think about it like it's a number line, right? 49 to 61 is the range for Smith. Then for Thomas is 39, which is below 49, then to 51. Well, where's 51? Above. So is there overlap between these two? Yes, there is overlap from 49 to 51. So because of this overlap, can we clearly project the outcome? No, because of the overlap from 49 to 50 to 51. So then 14 and 15 also showed another way of looking at margin of error. So here the margin of error is $11. So this is the estimate that we're starting with, and we're looking to see which of these population means is plausible. So again, add and subtract the margin of error, the 11. So now we're at 46 after subtracting 11 and adding 11, which is 68. So which of these is plausible? Which falls into this range here given the margin of error? That's why the answer is B, 54, because 42 is below and 69 and 72 are above. Then same thing here. You're given a margin of error of 5%. This is what we're going to add and subtract to here, that percentage of people who support the taxes at 72%. We're looking to see which value falls within the confidence interval range. So again, we're going to create that interval. We're going to add and subtract 5. So now we're at 67% and we're at 77%. So that's why here, if you look at the percentages, the answer is A. 63.5 is below and 78 and 81 are above. So now 16, given this situation, we're assuming that they can only select 200 students. Which of the samples would produce the best estimate, the most accurate? So remember sampling methods, the most accurate, if you've got it, is that simple random. So here we're going to randomly select 200 10th grade students, but that's just from the 10th grade. What about 9th, 11th, and 12th? So nope, not as accurate as it could be. So then here, we're going to select 50 students from each grade level. Now this is accurate because this is your stratified. So we'll keep this one and keep going. We're going to randomly select 200 students in 6B lunch. Well, what about 4th, 5th, and even 6A? This is like just with the 10th grade. So again, we're going to keep going. Randomly select 200 female students, but what about all of our male students? So due to these singling out and focusing where everybody in each grade level now has an equal chance, this is going to be our most accurate. So even though it wasn't simple random, here is stratified. So now here, going through, we have 318 members, but now we're looking for which methods would represent the most biased. So now remember most biased, that's like convenience where it's easy access, or self-select where it's volunteer based. So like 1, asking 20 members to volunteer. There's your self-select. So I can already tell that's going to be one of our most biased. So I can cross out B and D because I know I need the first. So now let's look at the fourth, because I'm going to use my answer choices as my guide. So I'm going to cross out 2 and 3. And also notice they're actually, if you read through, they're simple random. We're going to select 10 of younger members and 10 of older members, or survey 20 members who arrive at the next club meeting. So this is convenience, who arrives at the next meeting. So here 5, but again, you have 10 younger, you have 10 older. But what about everybody else in between, right? So that's why the answer here is going to be C. Then here, a study was given, but you had to identify if it was a survey, observation, or experimental study. There was a study of 1,000 people aged 20 to 30. All they had to do was they were asked how much television each person watches, and how much the person would rate themselves. Then the study showed these results at least 2 hours every night. But in the end, what were these people? What was what did we do with the people? All we did was just ask them. So this is only a survey because all we did was ask these participants. Now, does this mean that watching television for at least 2 hours every night lowers the energy level? Well, no, because this is just a sample, 1,000 people and only 20 to 30. Again, does this sample truly represent the population? Is this an accurate reflection? No, because we have all other grade levels. We have other ages here besides thinking about the people that are 20 to 30.